How's it going, everybody? Welcome back to another .NET video. So I want to walk through two running APIs I have locally, and one of them is the car data API that we've looked at before on the channel. Another one is the engine data API. So I want to walk through exception handling, throwing exceptions, exception messages, and how does one API handle when another API calls throws an exception. So we're going to get into this. And I first want to just show you how I have it set up currently just for our example here. So I'm going to call our endpoints, and let me actually get rid of my breakpoints so that way it'll just go through. And this is the response. So you can see that this endpoint engine get engine returns a status code of 500. So response status does not indicate success, throws a 500. It tells you where in the controller and in the service. But if you ever worked with .NET and you've ever seen errors, propagated in your logs, or you're maybe debugging locally, you know that this kind of error handling is basically useless, right? It does nothing more than tell you that something happened that shouldn't have happened, but it doesn't lead you in any direction. It makes it very challenging, especially when you're working in an environment where you have a lot of running services at once, all kind of dependent on the response of another service. So the endpoint that we called specifically is this endpoint right here. So all we're doing is calling get engine data, and let me go to the implementation of that. You can see that we're making HTTP client request out to my car controller get config endpoint, which is this endpoint right here in my car data API on the left. So you can see that I'm just fetching a value from my configuration file, so the app settings.json file. And I'm checking, obviously, just for the example, I'm checking that, hey, is that environment? If it's not equal to stage, we're going to throw an exception. And in this case, we're going to say bad environment. So I want to set a breakpoint on that response in my engine data API. And let's actually call this again, and let's look at that response. So I'm going to step over that there. And if you look at the response, you can see that I have the status code of 500, which is good. Reason phrase is internal server error. And status code, internal service error, not a whole lot. And unfortunately, that doesn't give us a whole lot to go off of. We can read that, the content. We can read that and look at what the exception message was. Like, we could say that, hey, okay, if it's not a status code, let's continue actually to read the content as a string and see what the response is. But that still feels like a little bit of not, the best way to do things. And so I have, I'm throwing in a request exception here. So ultimately we're going to, propagate that 500 we got from the upstream service. But what I want to show you is an alternative way where you don't have to just arbitrarily just kind of throw exceptions and hope that your calling API handles that appropriately. And I want to show you how to do this with basically result types or some kind of response object that basically will not only encapsulate the data, but also the status code, the optional exception, everything that you need. So this is a more functional programming inspired approach where you don't really want to throw exceptions, but rather you propagate the result or the result in a specific type. So you can see that this is my original approach here. Check, hey, it's not staged, throw an exception. But now I want to show you is that, hey, instead of just arbitrarily throw an exception, let's actually, I do want to change it to log error. Let's go and log that error, and then, environment variable, whatever, put whatever log message you want. But now you can see I have this response class defined, and I just define it below just for the sake of Honestly, screen real estate on kind of this recording here, but you can see that I have a generic class response, and I have this property here for message. Going to take that type that we pass in, and then I have exception. I just call it optional exception because it's not required. Succeeded as a potential property you could pass in, but I also have the status code, which is going to be very important for us, and extra data. But you can put whatever else you want to do on there. You can put links on there if you need links from your response. You could put additional like inner exception messages if you want to drill into that. You can put whatever you want on this, but basically this is going to be our result type. So if we go here, the next approach is going to be, hey, if it's not stage, let's go ahead and log that error, and hopefully your logs make it to whatever logging system you happen to be using. But then I'm going to build that response object. So I know that my response, I'm just going to pass in string for that, into that type there for message, and I'm just going to say wrong environment, and we'll say like, I don't know, it should be dev, just for the sake of the example. And then I'm going to pass my status code, bad request, so it's going to be a 400. Optional exception, I'm going to do a new exception, incorrect environment, in case we need it, and succeed as false. And I'm going to return that status code that we sent on that response, as well as the response object itself. So let's go ahead and restart this application. Let me actually comment that. Whoops, let me comment that out there and restart this again. So it calls. And let's pull Chrome back open, and we're going to call that again. And let's continue that. Alright, so this time what you can see is that now instead of the 500, we're getting a 400 in here, but it's not quite right because we're 500 and then 400 there, so not quite right. Let's go back and look at what we're actually doing here. We had some additional handling set up for our original approach for seeing if this API threw an exception. We actually checked here, hey, if it's not a status code of success or 200, we're going to throw new HTTP request exception, right, with that status code. So we're actually going to get rid of that, or rather, let's comment that out. And now what you can see is that now what we're going to be doing actually is redefining that response class below. And so this now is going to be a rather common, contract, for lack of better words, of that result type. So we're going to have response, and you can see we have some shared properties across here. I don't have extra data defined here just because it's not used, but one consideration that you do want to make is that if you do take this approach, you will either need to keep those, the interface in sync, or you should define in one central place, maybe like a shared library or something like that. So let me go ahead and restart this now that we're actually just going to be reading that from JSON async. And we passed in that response as the type. All right, so let me call this again and continue. So now our response is going to look a little bit different. So if we go here, you can see that instead of like that crazy error message that we got, now we get this message here. So we get a message, wrong environment, should be dev, optional exception, the exception that we threw, and we get succeed as false and status code of 400. So no exception has been thrown, but yet we get a very clear, hey, this is this is what happened, and we do in fact have an exception that was thrown. So now that sets us up for going back into our engine controller, that sets us up really well because not only do we not have to really like care so much about drilling into like the raw code on the HTTP client, and also the controller now doesn't really have to care that much about what the service truly does, and I think that that's a good thing. Because the controller, I don't like having the controller super dependent on like the business logic stuff of the service. I think that the controller should just be routing a request and returning the response, and that's it. It shouldn't really have to know anything at all about any of like the service data at all, because that should be the responsibility of the service. If the service needs to throw, it should throw. If the service needs to return, make an additional call, do a retry, it should do all that. The controller, in my opinion, should just be responsible for just the raw routing of your requests and your response. And so this approach here, now I can just return a status code with that status code from my result, which is the response type, and then the response body, which again is the response type. So this is a really, I think, clean approach because it effectively sets us up in a place where we can do a lot of extra considerations. We can kick this message back to a queue. We can retry it. We can move this to a dead letter, and so on and so forth. Now, obviously, we probably don't want to do this here. So let's say, we can leave our controller to literally just be that, regardless of what happens, right? Because I just don't think the controller should have any functional knowledge at all over service. I take a really strict approach to that because whenever you have a really bloated controller, the temptation there is that you start incorporating business logic into your controller. And the second you do that, you break the separation of concerns from, between your controller and your service. You want those two things to be very distinct. The controller does routing, the service does business logic. And with this approach here in our engine data, we can do the same type of thing here. Once we've read that response, let's say, is our content, has it succeeded? If it's not, we can retry. We can add, 1 to the retry count. We can move it to a dead letter. If we're working with, let's say, a message broker, we can say, bus dot, send, whatever. However we're choosing to do that, we can do something like that. We can do a lot of things. We can log the error. We can log a warning. We can do a lot of things, but it separates us from having to worry about whether or not the API that we call through an exception. It separates us out from worrying about, hey, what potential, how is that response going to come through? Because if we define that contract across our APIs, it sets us up to be really in a good spot where you can share, you can have some understanding of what you're expected to get back. And I think this is pretty good. And let me see here. So, all right, let me go back to controller. Let me stop and rerun this. And let me get those changes in. And let's actually go back into here. And all right, let me flip-flop this so that way we actually hit our success log here. And let's just look at what a successful message could theoretically look like. Execute that, and I'm going to get rid of this breakpoint there. Okay. All right, so you can see that our response now is we have a message, we have no exceptions, we have succeed as true with the status code of 200. And I think that that's pretty clean because we can put whatever we want in the message. We know there are no exceptions. We saw it succeeded, and we get a status code. And I feel like not only does this make the logging potentially a lot cleaner, but we have a greater understanding of what the API that we called is doing, whether or not, because sometimes, exception throwing is actually quite difficult because sometimes if you just throw an exception somewhere, you don't know how the calling code is handling that. Because if the calling code has its own exception handling, it might be like just swallowing that exception and you'll never see it. And so you have to make sure that your exception, if you do throw it, is propagated to the top of the stack, right? Because if you throw an exception and it gets lost, what good is the exception apart from maybe it getting caught in your logging system, which then warrants, the begs the question of, well, maybe it should just be a log message in the first place. So exception handling is difficult because it poses a breaking state in your solution. It puts your code in a weird state. And so I would really lean towards railway-oriented programming as like a potential fix for this problem. We didn't do it here, but if we were going to take this a step further, we could design, or we could take functional programming elements of this and turn this more into like some sort of pipeline, which we showed and worked on this channel. And a lot of that comes from the concurrency in .NET book that we've talked about at length on this channel. But again, I would just try this out, experiment with this on your own, like just have 2 running services locally. And then just play around with like what works and what doesn't for you for like, calling endpoints. How do you want the response structure to look? What makes sense in your system for exception and exception handling? Do you need a global exception handler? That may be a question that you have to ask, and maybe something you potentially have to implement. Do you want to get more granular in terms of like, your exception messages and everything like that? So anyway, I just want to talk about this because it's a big topic and I think it's worth experimenting with. So thank you all for watching. I'll see you in the next one.